Hi, it's Mrs. Gregg. I know a couple of you are having problems as far as the solutions and dilutions homework that we're doing. So I wanted to do the first problem so that we're all on the same page and we understand what's going on. Okay, first of all, the equipment that you need in order to make a solution or to make a dilution, we have a balance, we have a graduated cylinder. These are volumetric flasks that we have never used before, and I'll talk about this in a second. And then you have a pipette, and then this is an Erlenmeyer flask. All right, the thing that's special about the volumetric flasks is that they come in specially set sizes, and they have marks on the neck. Here's a mark on the neck. They have marks on the neck that indicate the exact volume that they're designed to measure. So like for this 100 ml flask, the only mark that it has on the entire volumetric flask is a single mark that indicates where that 100 ml volume is. So the only thing that you can measure with this 100 ml flask is exactly 100 milliliters. There's no other marking on there. There's just a marking for 100 milliliters. Okay, if we go all the way up to the 500 ml flask here, there's a single mark on it, and that's whenever you're pouring liquid into it, whenever you've reached exactly 500 milliliters. Okay, so the first problem that you have is how are you going to make 450 milliliters of a 0.25 molar sodium hydroxide solution? Okay, the first issue with that one is that there is no such thing as a 450 milliliter volumetric flask. So we can't use these, and we're left with using the Erlenmeyer flask, which is not going to be quite as exact. These volumetric flasks are really ideal for making solutions, but we're left with using the Erlenmeyer flask. Okay, the first thing you want to do is figure out sodium hydroxide is going to be a solid. We need to figure out exactly how much of that solid we're going to need to dissolve in liquid in order to make 450 mils. Okay, so we use the equation that the molarity of a solution is equal to the moles of the solute over the liters of solution. And the big thing here, again, I had a video where I talked about the fact that it's the total volume of solution. So that's not just water. That would be water plus the sodium hydroxide. All right, so we use that equation for molarity, and we can rearrange it to figure out the moles of sodium hydroxide that we need. So the moles of sodium hydroxide, that's going to be the molarity, which is the 0.250 moles per liter. That's what molarity is measured in, times the volume of the solution that we want, which is 450 milliliters, which you can convert to 0.450 liters. Okay, so we figure out that we need 0.1125 moles of sodium hydroxide. And then we can use the molar mass in order to figure out exactly how many grams of sodium hydroxide we need. Now, to do this in the lab, if we were going to make this solution, first thing you do is you use the balance to measure out exactly 4.5 grams of sodium hydroxide. And then we're going to pour that sodium hydroxide into the Erlenmeyer flask. So we add it to the Erlenmeyer flask, and then you're going to pour liquid. In this case, we're using water. We're going to pour water into the Erlenmeyer flask and keep pouring until we reach that 450 ml mark, which I'm going to pretend that it's right there. And once you have 450 mils total in there, now remember that's the total of the solid plus the water that you just poured in. Once you reach 450 mils, then you stop. So it's a little bit different than what some of you are showing me. You can't put in your mass of sodium hydroxide and then add 450 milliliters of water. It won't work that way. If you do that, you're going to end up with more than 450 mils of solution, because adding in that sodium hydroxide, that adds mass, that adds some volume to that container. So then if you have the sodium hydroxide down in the bottom here, and then you pour 450 milliliters of water on top of it, you're going to have more than 450 milliliters of solution. Okay, so you have to always keep in mind that whenever we're working with these molarity problems, that it's the volume of the solution, and the solution contains both the solute and the solvent. So we're having to account for both the sodium hydroxide and the water in there. So typically, just to kind of summarize, typically when you make a solution, you start out with the mass of whatever solid that you need, and so I'm dropping some powder down in here, and then you pour the liquid in until you reach the mark. Let's say that we want 500 mils. There's a 5. Until you reach the mark for the volume that you want. Okay? You can't say that you're going to take your flask and put your solid down in here, and then I'm going to come along, say, with a graduated cylinder and pour in 500 mils. That won't work, because then you're not going to have 500 mils. Wow, this is not right. You're going to actually have more than 500 mils if you do it that way. So it's always add the solid first, then pour the water on top until you reach the mark for whatever volume that you need. All right, I hope that helps, and I am going to try to put together some other videos for you. In the meantime, the YouTube ones that I'm finding for you, I think they're really helpful. If you think it's too long, just double speed it or something and fast forward through it and watch what you need. All right. Again, hope that helps. Talk to you later. Bye.